So yes, let's go to a meta-analysis or to the meta-analysis section. What is a meta-analysis? Any idea? Yes, statistical analysis. Yes. Okay, so the meta-analysis is basically getting the collective result from the included studies and combining all those studies together, considering all studies as one sample, and then giving the overall outcome or the final outcome of interest. So I don't look at the result of one study only. I will look at all results combined together and one big sample from the included studies, and I will get the final conclusion based on that. That is why the meta-analysis gives more reliable conclusions because it combines all studies together. So instead of getting 30 patients in one sample, I will get maybe 500 patients in one sample because I am combining all studies together. Is that clear? Okay, so for example, here we had 10 studies included in the systematic review. But 5 of those studies reported the percentage of bone formation, and they compared maybe bone graft A versus bone graft B by reporting the percentage of bone formation. So I can do a meta-analysis by combining all studies together and getting the percentage of bone formation when I compare graft A and graft B. Now let's make this clear into one example. So when we want to read and understand the meta-analysis, this is the most important figure that we need to understand, which is what we call a forest plot. Okay, so here is a meta-analysis that compared primary implant stability. Do you know primary implant stability? Okay, so implant stability, it means how stable, how tight this implant. Is it shaking or it's stable? Now we measure implant stability using this device. Then we just make it near the implant and it will give us a number. And the higher the number is, it means what? Better or worse? Better, yes, it means the implant is more stable. The implant is actually tight. So here is a meta-analysis that compared 2 bone grafts, compared ADG and BioOS regarding implant stability in that site with this bone graft. So we have indented sites, we have sites with missing teeth, and these missing teeth got the ADG in the test group and got BioOS in the control group. So we have several studies done on this topic, and now we combine those studies in one meta-analysis to see whether this graft gives similar implant stability to this graft. Okay? Now let's try to make this clearer again. So when I look at forest plot here, this figure, I need to understand many things. So just wake up and let's pay attention together. The first thing I want to understand is those green squares that you can see here. Now each green square here represents one included study in the meta-analysis. So here in this meta-analysis, how many studies were included together? 3 studies, yes. So I have 3 squares, and each square represents one study. So I have 3 studies. As you can see here, I have June 2014, Khan 2017, and Santos 2021. So I have 3 studies combined together to do the meta-analysis. Now, the next thing I want to understand is the location of that square. Now, if we look at the first square here, we can see that if we go down, it's in the negative side. It's around -5. Why is that? Oh.
The main score is lower.
Very good. Thank you, Isi. Yes, very good. All right. Because ADG had lower mean stability, as you can see, 64 compared to BioOS, which had 7. So if I subtract those means, if I subtract those 2 numbers, I will get what we call the main difference, which is a negative number. So here, as you can see, 64 and 70, like minus whatever, and then you get 5.67. So that is why here the square is on the negative side. Okay? All right, just keep it as it is for now. Things will become clear more and more later. Now, how about this one? Why is it on the positive side? It's around 2.5. Why? Okay, very good. Yes, thank you. Because ADG has a higher mean score, higher mean implant stability compared to BIOS, which is 70. So 72.8, 70 minus, basically we'll get a positive number, and it is like this. Now the last one is at 0. Why? Around 0, basically, the last square. Yeah, because the same values happen here. Like in the test group, in the ATG group, we got 77.1, and BIOS we got 77, so it's around 0, and that is why here the square is around 0. All right? Okay, so this is the first thing we need to understand. Here we have the studies, 3 included studies, and the location of that square depends on the result from that study. Now, after that, we need to look at this line that crosses the square. So we have this line here. This line represents the range of the 95% confidence interval. So if I look at the first line here, I can see it's from around -11 up to 0. Why? Because here the 95% confidence interval is -11.71 up to 0.37. Now that is why I have this line. It represents this range. Okay? Alright, now how about the next line here? Why is it longer than the first line? The second one. Why is it longer than the first one? Why? Please tell me. Please don't feel embarrassed of making the wrong answer. Very good. Yes, thank you. Thank you, yes. So because here the range of the 95% confidence interval is wider than the first one. So that is why the longer here the line is, means the bigger range, the wider range of the 95% confidence interval. Now the third line is very short. Why? Same, because basically the range of the 95% confidence interval is smaller here, so that is why I have a shorter line. So the line again represents the 95% confidence interval, and it means how wide or how narrow it is. Now, the next thing we have here is the line of no effect. Oh, sure. Yes, exactly. So here each number and each 95% confidence interval represents the result of that study here. Yes, one step. Okay, the next one that I need to look at is this line, the line of no effect. I call this the line of no effect. Here it means that there is no significant difference between the test and the control group. So if I have the line of here, the 95% confidence interval touches the line of no effect, what does that mean? What do you think this means? Again, the line of no effect represents that there is no significant difference between the test and the control group. So if I have this line touches the line of no effect, what does that mean? Yeah, very good. So it means that in that particular study in June 2014, there was no significant difference between the test and the control group. So there was no significant difference between ADG and BIOS. All right. Now, how about the next 2 studies? Is there a significant difference between the test and the control group? Yes? No. Because the line here and this line and square touch the line of no effect. It means there is no significant difference between the test and the control group in that study. All right. Okay, very good. So I know now what each square represents, and I know the line of no effect. The next most important thing I need to understand is this black diamond. This black diamond represents the final result of the meta-analysis, combining all studies together into one big sample. So this is what I need to look at when I need to find the result of the meta-analysis. So the lower angle of that diamond represents the final number of the meta-analysis. So if I look at the lower angle, it's around -0.5. I hope that you can see, because this is the result here of the meta-analysis. So this is the final result. It's -0.74. So the lower angle represents that result. Do you understand? So yes, the lower angle here represents that result. Now, the diamond is a little bit different than those squares because the left and right angle represents that represent the 95% confidence interval. So when I have a bigger range of the 95% confidence interval, it will be a bigger diamond. Do you understand? So again, the lower angle is that number, and the right and left angle are basically the 95% confidence. Is that clear? Okay, now this diamond touches the line of no effect. What does that mean? No significant difference, which is the most important thing that I need to understand. So regardless of this number, I will just look at this diamond. The diamond touches the line of no effect. It means that there is no significant difference between the test and the control group based on the overall result of the meta-analysis, not based on one study, based on combining all studies together, I got this result. All right? And here comes the benefit of the meta-analysis. Sure. You use it, you do it using the software, of course. It will just like you will enter the data and it will give you those numbers. Unfortunately, we cannot really study this together, but hopefully I will be explaining it in the future if we have another chance. All right. So yes, here comes the benefit of the meta-analysis, which is, for example, we had so many studies, or in this case, 3 studies about this new grafting material, and we need to know if it is good as other bone grafts, yes or no. So I included all those studies in one meta-analysis, and I got that the ADG, the new bone graft, is as good as BioOS, which means that I can use this graft successfully for implant placement, and it will give me the same implant stability. Do you understand? So this is why we do meta-analysis, just to confirm is this new material good? Is it bad? Or is this new drug good or bad? Something like that. But I want more conclusive evidence. I don't want to look at one study. I want to combine all studies together. And by combining those 3 studies, I got that this ADG is as good as BioOS because it gives similar implant stability. There is no significant difference between those 2 grafts. All right? Okay, now here is just something very easy. This is, again, to confirm the no significant difference. We have p-value, which is 0.58. It means no significant difference.